All right, tonight we're going to talk about astronomical measurement. Specifically, how do we determine how far away things are in space? Measurement in space is a whole new world. Okay, we don't use miles. Miles is about as long as you get on the Earth. We use other units. Now, to start out, one of the first units we'll use is something called light years. And light years is probably the one we'll talk about the most. Just to give you a sense of scale, the universe itself is about 93 billion light years across. That means that a photon of light at this end of the universe takes 93 billion years to get all the way over to this end of the universe. Now, incidentally, the universe is only 13.7 billion light years or billion years old, so that photon of light has only made it a short distance across the universe. So it hasn't even had a chance to make it across yet. So, it just gives you some idea of how vast things are. It's also equivalent to something called 28 billion parsecs, and we'll talk more about parsecs in a little bit. You also do a lab dealing with parsecs. But all these little bright areas, the red and yellow, are dense clumps of matter, and everything else is kind of relatively empty space. But this is the universe as mapped by the WMAP project. Zooming on into to the center of that map, where our something called the Virgo supercluster is located. The Virgo supercluster is a supercluster of galactic clusters. So galaxies are grouped in clusters, and then those clusters of galaxies are grouped in superclusters. Our supercluster, known as the Virgo supercluster or the local supercluster, is 110 million light years across. There's us. There's Virgo, the Virgo cluster, and there's the Andromeda group. M81 is Andromeda, and so on and so forth. So this is still a pretty big distance, but let's go ahead and zoom on into our galaxy. We'll just skip over the local group. Our galaxy is 100,000 light years across. So it takes a photon of light 100,000 years to make it from this point to this point. There's the center of the galaxy. You can see the galaxy is actually a barred spiral. The center is bright because there's a supermassive black hole pulling matter in and heating it up and energizing it. We are located about 1/3 of the way out from the center of the galaxy. It actually looks like a little more in this picture, but in the Orion spur of the Perseus arm, I believe, of the galaxy. And so that's our neighborhood. There's about 100 billion stars in the Milky Way galaxy alone. We zoom in on our solar system. The outer reaches of our solar system are represented by this blue line. It's called the Oort cloud. It's about 1 light year from the sun. So it's about 1/4 of the way to the next star, actually, Proxima Centauri or Alpha Centauri. Zooming in, I'm pushing Prezi to its limits here as far as zoom goes. Not yet, but soon I will be. This is the orbit of Sedna, this red line in here. Sedna is a dwarf planet outside of Pluto's orbit. It's about 1,000 astronomical units from the sun. We'll talk about what that is in a moment. But that's pretty far away. Pluto's 40 astronomical units. Sedna's 1,000 astronomical units. On average. It's a very elliptical orbit, as you can tell. Highly elliptical. Zooming on into the solar system itself, this purple orbit is Pluto. And you can see where it crosses over the Neptune's orbit. That's Sedna. So now this is 40 astronomical units from here to here approximately. Moving into the next zoom. Trying to zoom in closer to the inner solar system, which, here's the orbit of Jupiter, here's the orbit of Saturn. The inner solar system is still this tiny little dot in there. Zooming in on that, of course, 1 astronomical unit is defined as the 93 million miles from the sun to the Earth. And, that's what 1 astronomical unit is. So Sedna is 1,000 of those away from the sun. I mean, that's as far as Prezi will let me zoom. So there's the Earth. I don't know why. I just thought it looked cool. This picture kind of looked cool. Anyway, what is a parsec? I mentioned this thing called parsecs. I think we all intuitively understand what a light year is. Nothing else from Earth science. We know what miles are, and I think we've heard about astronomical units before. Parsecs are maybe new to you. 1 parsec is equivalent to 3.26 light years. Now, how do we determine how far away a star is, or an object, in parsecs? Well, there's a little geometry and trigonometry involved. So we identify a star whose distance away from the sun we would like to determine. We measure where that star is in the sky on one day, and then 6 months later we measure it again. And we can then draw these neat little angles, these neat little lines. We know this distance is 1 AU, and we know what this parallax angle is because it's the same as this angle over here. So if we can determine this angle here, we can then determine this angle is 1 arc second. So you have degrees, then you have arc minutes, then you have arc seconds. So 1 degree is made up of 60 arc minutes. One arc minute is made up of 60 arc seconds. So if this angle is 1 arc second, then that star is exactly 1 parsec, or 3.26 light years away. Now, the closest star is 4.25 light years, so there is no star that's 1 parsec away. But this is just an example for discussion. Now, you might think to yourself, well, that's great, but what happens if the star is really far away? And, or as my 4-year-old likes to say, really far away. Then obviously the angle gets to a point where you can't measure it anymore, and you can't really determine parsecs that way. So this is just your basic. This is the 1 arc second and the 1 AU, and from that information you can determine, and of course, the distance here, 206,265 AUs is 1 parsec. That's the equivalent to 1 parsec. But the bottom line is, knowing this is 1 AU and knowing this is 1 arc second, you can then determine how far away the star is, which is this distance from S to D here. All right, so here's some conversion factors for you. You might want to write them down. They might find them to be useful at some point. Now, how significant do you feel? Do you still feel big? That's the question I'll leave you with.